Okay, part 5.5, part 2 is talking about solving equations that involve multiple angles. So it says if x is a measure of an angle, then for any real number k, the number k times x is a multiple angle of x. So, such as sine of 3x, cosine of 2x, cosine of 4x, things like that. If it has a number in front of the x, it's considered a multiple angle. Now remember, a number being divided is the same as it being multiplied times that reciprocal as well. But we'll talk about that more later. All right, so number 1 here says find all solutions in the interval from 0 to 2 pi of the equation cosine of 2x equals 1/2. So just like before, remember cosine, it's a positive 1/2, so cosine's positive in quadrants 1 and 4. So we're going to have a quadrant 1 answer, and we're going to have a quadrant 4 answer. We also know that cosine is going to be our x value. And we're going to put, because for my angle here I have 2x, so we're going to put 2x equals. And so, what angle in quadrant 1 has an x value that is 1/2? And it should be pi over 3. And then, even though it says from 0 to 2 pi, if it's a multiple angle, we've got to be able to put the plus 2 pi in, because we haven't solved for x yet, and there could be multiple answers to each part then. Alright, so plus 2 pi in. Let's do the same thing for quadrant 4. So what angle in quadrant 4 has an x value that is 1/2? And that should be 5 pi over 3. And then we're going to put our plus 2 pi in still. Remember, we use 2 pi because it's cosine, and that's the period of cosine, in because it could be multiple times around. Alright, so to solve both of these for x, so we're going to divide everything here by 2. And so we get x equals, remember dividing by 2 is the same as multiplying by 1/2. So we get pi over 6 plus pi in. And we divide this by 2. We get x equals, same as multiplying by 1/2, so 5 pi over 6 plus pi in. And so, if you watch the videos that come with the My Math Lab, they just start picking some random numbers and try to plug it in and see what works. But I have a little more organized way, and it's a table. So we're going to pick some n values, and we're going to plug it into each of our answers. So we're going to plug it into pi over 6 plus pi in. And we're going to plug it into 5 pi over 6 plus pi in. Now, I need to pick n values in which my numbers at first are going to be too small, so they're going to be less than 0. And we're going to keep going until we get numbers where it's bigger. My answer would be bigger than 2 pi. So, usually we start with -1. If we need to go smaller, we can. So when I plug in -1 here, I get pi over 6 plus pi times -1. So really that's like minus pi. And so when I do that, I get -5 pi over 6. That is not between 0 and 2 pi. Now, try 0. When you plug in 0, you get pi over 6 plus pi times 0, which is 0. We get pi over 6. That is between 0 and 2 pi, so that's definitely going to be an answer. Then plug in 1. So we get pi over 6 plus pi times 1, which is just pi, which is 7 pi over 6. That is also between 0 and 2 pi, so 7 pi over 6 is also a solution. And let's try 2. So we got pi over 6 plus 2 pi. When we add this together, 2 pi is the same as what? 12 pi over 6, so we get 13 pi over 6, which is too big. But hopefully when you realize you were taking 2 pi plus a number, that meant you were going to be bigger than 2 pi, so it was automatically going to be too big. So out of just this one piece of the problem, I did get multiple answers. I got 2 answers there. And so now we're going to do the same thing with the 5 pi over 6 plus pi in. So I'm going to plug in that -1, which means I'm going to be subtracting a pi. So I got -pi over 6. That's too small. If for some reason it did fit in, then we would just have to backtrack a little bit further, try -2. But usually -1 doesn't work, so you're good. Then plug in 0, so 5 pi over 6 plus pi times 0, which is 0. And 5 pi over 6 is between 0 and 2 pi. It's on our unit circle. So 5 pi over 6. Now we're going to plug in n as 1. So we got 1 times pi, which is just pi. So that's 11 pi over 6. That's also on my unit circle, so that's an answer. So we got 2 so far. And then try adding when n is 2, so we're adding 2 pi. And again, we've got something bigger than 2 pi, obviously. And so that won't work either. So with this one problem, we ended up with 4 solutions. So we've got x is pi over 6, 5 pi over 6, 7 pi over 6, and the 11 pi over 6. And all 4 of these will work when we plug them into our solution, or into our problem, excuse me.